Hello guys, today we will be solving the question of code forces game of division. So this question is not that hard, but I wanted to discuss this question with you guys because this question has one another approach which can question can also be solved in big of n time. So I'll discuss in this video I'll discuss both the approaches with you. As the constraints are very small, like we can see that the constraints are really very small. N is either small or greater than less than 100, and k same goes for the k. So we can directly use the approach of n square, uh, but there is one more way to solve this. So let's discuss first the brute force way, how we'll discuss. So let me explain first what the question is. So in the question we are given with two players which are playing the game. Let's say they are Alice and Bob, and we are Alice here, and here the condition is if the first player wins if a of I is not a of I minus a of j is not divisible by k. This is the condition if the first player wins. So let's say we are Alice and we want to win the game. So our approach would be we will choose a of I such that when I subtract it by any number a of j, it should not be divisible by k. It should not be divisible by k. So I will keep this in my mind. So that will be my approach. I'll find a of I such that it is when I subtract that number by a of j, it should not be divisible by k. If I am able to do so, I'll win the game or I'll lose the game. So our aim should be to win the game. So let's see a test case here. Here n is 3 and k is equal to 2. So first let's see this number. So if I'll compare 1 and 2, then I'll see the difference between 1 and 2 is 1, which is not divisible by k. Then we will proceed to the next number, 1 and 3. So the difference between this is 2, which is divisible by 2. Yes. So we can't choose 1 here. So let's move to the next number, 2. Let me erase this first. Okay. So now we will move to second number, 2. So I'll first check with 1 if it is divisible. So the difference between 2 and 1 is 1, so it is not divisible. Then we will move to the number 3. We will not check with the number itself. Now we will check with 3. The difference between 3 and 2 is 1. So indeed, yes, we found the answer, and the answer is 2. So we have to return the index. So the index will be I plus 1 because we are dealing with 0 based indexing here, and we need to return in 1 based indexing. So our answer will be I plus 1 whenever we will find such number which is not which on subtracting with a of j is not divisible by k. So yes. So here is the code for this. So first I will simply take the inputs. First I'll take the inputs here and inputs. Then we will take two loops. One for keeping a of I and second for checking a of j. Then we will see this condition. If a of I minus a of j is divisible by k. If it is divisible by k, we will just make this variable equal to 1. It means that we can't move forward with that number. We have to move to the next number. We have to move to the next ith value. So we'll simply break, and if we have not found any condition here, like if we have not encountered this condition, it means that we have found the answer, and the answer is I plus 1. Okay. So this was the brute force approach which you all must have done. So the complexity for this is big of n square because we are using two loops which goes until n. Okay. So now let's discuss the second approach, how we can actually do this in big of n time. So let's first see the test case. Here k is equal to 2 and we are given with this array. So let's see what we can do. So first we will go to the first number and we'll check with 3 the difference is 1, so we can move. So with 6 the difference is 2, it means it is forming a pair, then we will cancel 4. Let's move to 3. With 3 difference between 3 and 4, this difference let me erase first. Okay, so difference between 3 and 4 is 1, so we can move forward. Difference between 3 and 6 is 3, which is not divisible by 2, so we can move forward. Difference between 3 and 2, it's the absolute difference, then the difference is 1, we can move forward. Then difference between 3 and 5 is 2, so this is divisible by 2, then we have to cancel the number 3. Okay, so let's move on to the next number. Here you can see that 6 difference between 6 and 2 is 4, which is divisible by 2 or k. Then we will move to 5, which is divisible by 1, which is like we can cancel it at that time or 2. So we will now move to the next number. Now for 2 you will see that here you can see that the difference between 2 and 4 is 2, so we can't move forward with 2, so we have to cancel this. Now let's move on to number 5, and you will see that with number 5 there is a pair with 3, which with the difference of 2, so we can't also move with 5, so we have to cancel that. So here we saw that none of the numbers are there which doesn't form pair with any number, so we can't choose any number from this, so our answer will be no here, because there is no number, or there doesn't exist any number which doesn't form pair with anyone else, so the answer will be no here. So let's see another test case. So one thing I have to tell you guys that, so we have observed the situation here that if a number doesn't form pair with anyone else, then we can say that yes, it might be the answer. Let's clear up the things at the next test case. Here k is equal to 2 and array is this. So let's see what we can do. Let's move to 4. We can see that 4 and 2, the difference between these two guys are 2. So we can't take 4. So we will cut this. Then we will move to 5. Can I make pair of 5 with any of these array numbers? So can I make this? Can I make up this with 4? The difference is 1. So yes, this 1, this 1. So none of the difference was divisible by k. Then I can say that the 5 is our answer and its index is I plus 1. So here the observation is that 5, the remainder of 5, so 5 divided by k or 2 is 1, and everybody else like 4 divided by or 4 remainder 2 is 0. Similarly 6 remainder 2 is also 0, and 2 remainder 2 is also 0. Yes. So we have to find a number such that its remainder is unique, or we have to find such number which whose remainder is unique in the whole array. So we can see like this. Let's look at into a data structure first. Like how can we approach this? So I'll first how we can do in big O of n time. So let me erase this first. So let's say I will move to 4. Then I'll store 4 in an array. So my array will look like this, and I'll take another array of k length, and there I'll store, let's say the array is b, and I'll store, and this array is a of I mod k and plus plus. I'll do this. So when I'll perform this operation, so when I am at 4, so it will at the b array it will look like 0, because here will be 4 and mod k is R2, it will be 0. When we will move to 5, we will see that it will be 5 mod 2, which is 1. Okay, then we will move to 6. 6 remainder 2 is 0, so so it will increment here. So we will simply increment this position. So it was basically 1 here, and it is 1, it becomes 2 now, because 6 is also divisible by 2, and it goes here. When we move to 2, it is also divisible, so it becomes 3. So our array looks like this. Here array is 3, 1. So we will see that if at any point at array, if there is 1, then we will simply return yes or no. Let's also look at this example. Let's say my array B something looks like this now, right now, and the positions are 0, 1. Okay, because my length of the array of B is 2, so this is 2 length array. So these are the indexes 0 and 1. So now let's iterate over the array A. This is my 4. So 4 divisible by 2, or 4 mod 2 is 0. So I'll make it here as 1. Then I'll move to 3. It is, so 3 mod 2 will give me 1. So the count is 1. When I'll move to 6, so 6 mod 2 is 0. Then this increment will increase. Then I'll increment this position, and it will become 2. Then I'll move to this position, then it will become 3 because it is divisible. When I'll move to 5, it is divisible. It on mod operation it will give 1, so I'll increment this. So at array B, we can see that none of the element is 1. So we can say that everyone is forming a pair with someone else. And in this test case, we saw that there was a number who was all alone, and he doesn't made any pair with any of the element. So we can directly say that this is the number which we are finding, and if we will choose this number, we will definitely win. So this is the code for this, and let me tell you, this is time complexity of big of n, and this is the code here. First we are taking the inputs, and this is my B array, and I'll just increment the A of I position every time. And like I said in this part, whenever I'll find a 1 position or 1 number, I'll directly return S. It means we have found the element, and we can say that we have won the game. Thank you.